Hi, hello to everyone. This is Dr. Satheesh Kumar, working as a associate professor in the Department of Information Technology at the Institute of Aeronautical Engineering, Hyderabad. In this session, I'm going to tell about the DFS algorithm in artificial intelligence. Okay, the DFS means the depth first search algorithm. So, in the previous sessions, just I given informed search algorithms. So, various informed search algorithms are presented in the artificial intelligence. How it will be, how they are for a specific algorithm going to be solve a particular problem and certain things. Okay, so from in this video, just I'm going to tell about some uninformed search algorithm also. Okay, so DFS algorithm will undercome the uninformed search algorithm. Just everyone knows that one. Okay, so let us start. So before starting, this is the overview of my presentation, the definition of the DFS and the working sets of the DFS and algorithm of the DFS and example. Just I'm going to give one example how we are going to construct and how we are going to visit all the nodes in the tree using a DFS algorithm. Okay, so let us start. So first, what is mean by the DFS? Okay, what is mean by DFS? Depth first search algorithm in artificial intelligence. So the depth search algorithm is a traversing algorithm. Okay, but it's especially just we are going to call the DFS algorithm is the traversal algorithm. Okay, it means from the given a tree. Okay, the DFS have to travel to A to Z. Okay, the source to destination, and along with your neighbors nodes, and we have to visit all the nodes. Okay, so here the DFS is going to be tell about the DFS is a traversing algorithm used in tree and graph like data structure. Okay, just everyone knows that data using the data structure, how we are going to construct on a tree or a graph with a neighbors node along with that cost of the each and every nodes. Okay, so especially the DFS is going to work on tree or either graph. Okay, so tree or a graph. Okay, the next one generally starts with exploring the deepest node in the frontier. Okay, just if we have a one node or one tree. Okay, just we know how we are going to construct one tree using some based on that node weights. Okay, so generally just we are going to start with the root node and parent node and child node and the leaf node like this. Okay, so each and every node just how we are going to insert with the and the parent node. Okay, so the next one is starting the root node. The algorithm proceeds to search the deepest level in the searching as a tree until nodes with no successor are reached. Okay, so while you are constructing one tree itself, the DFS algorithm going to analyze or search the deepest nodes which will come under after the root node. Yeah, right. The next one is it is a recursive algorithm. Okay, so DFS algorithm is also called as the some recursive algorithm. So what is the recursive? It will produce some effective output. Okay, it's the best output of the given problem. Okay, so that is a recursive. Just repeatedly it is going to be produce some successor rate. Okay, so if you are using the DFS algorithm also, it will produce the more successor rate based on this recursive algorithm. So such algorithm will take the tree data structure or graph. Okay, so the DFS algorithm starts with the initial node of the graph. Okay, so this is considered node here. This is the initial node. The root node is our source node is the initial node of the tree or a graph and goes deeper until we find the goal. Okay, so this one is a goal node means just that DFS node we have to visit all the neighbors. Okay, they will take all the neighbors and it will reach the goal node of in your tree or graph. Okay, so this is the concept of the DFS algorithm. So here just we are going to tell about the queue or search. Okay, queue some concept we are going to use stack. Okay, queue and stack. Okay, here especially in the DFS just we are going to use the stack concept. Okay, so just we are going to insert on a node and then we have to search the particular node is available in the particular stack or not. Then we have to move to the another strings. Okay. So this is the concept of the DFS algorithm in artificial intelligence. Okay, so how we are going to construct on a tree or a graph? Just everybody we know the based on the cost of the given node. This we are going to construct. The next one is step by step procedure. Okay, so how to we are going to process or implement the one tree using the DFS traversal concepts. Right. So the first create a stack. Okay, first step is what? Just we are going to create one stack. Okay, so this one is one stack, right? So with the total number of vertices in the graph. Okay, just we have one set of a graph already given. Some graph or present over the given a tree or graph. Okay, so based on this one, just we are going to create one a stack. Okay, so number of vertices. Okay, based on the number of vertices. Okay, so the next one is now choose any vertices as the starting point of the travel and push that vertex into the stack. Okay, for example, just is on A, B, C, D, E, F, G. Right. So here A is some starting vertexes, starting point of the travel from root node to child node to reach the goal node. Okay, so here now what is the point starting with the travel and push that vertexes into the stack. Okay, now just we are going to consider this one is a starting vertex. Okay, starting node. So now this A node A going to be pushed into the stack. Okay, just we are going to load into the that particular vertex node A into the stack. Okay, then after that push non-visited vertexes or adjacent to the vertexes to the top of the stack. Okay, non-visited means next node. Okay, root node, then parent node, then child node, right? So next to parent nodes are otherwise adjacent node of the particular starting node. Okay, so this starting node is here A. So what is the adjacent node of this A, B, and C, right? So B and C. Okay, so after that push a non-visited vertexes. This also just now we are going to B comma C. Now we are going to push into the adjacent node of the A is into the stack. Okay, so this is top of the stack. Okay, this one is a next before this one. The B and C is pushed into the stack. Okay, so now repeat the 3 and 4. Okay, until no vertex is left visible from the vertexes on the stack stop. Okay, now just we are going to print this A. Okay, now already visited node is A, node A. Now we have to print into the this vertexes A is into the print, and then next stack B comma C. Okay, now just again just we are going to repeat the step number 4 and step number 3 and 4 until the visit all the until the travel to all the nodes present over the a tree or a graph. Okay, if no vertices is left, go back and pop the vertices from the stack. Okay, so after completion of all the visit all the nodes of the from a given tree or graph. Okay, so if the stack if vertices are left, then we have to go back and we have to push into pop the vertices of the stack. Okay, so what is the stack vertices are available? Then we have to pop. Alright. The next repeat the steps 2 to 3 and 4 until the stack is empty. Okay, so until otherwise the stack it should be empty, we have to do the push and pop on the particular vertexes. Alright, so this is the process of implement the DFS traversal algorithm in the given graph or tree. Okay, so next one is algorithm. So what I have explained the step-by-step process in implementing DFS traversal, the same thing as we are going to write as a algorithm in artificial intelligence. Okay, so the algorithms is means what just everyone knows that step-by-step process, right? So just I given the theoretical oriented step-by-step process here, the same thing is I given the some procedure oriented algorithm in for your understanding. Okay, the set status equal to 1 ready state for each and node in a given. Okay, so okay, so here just we are going to get the starting node. Okay, A, B, C, D, E F G. Right? So here now what is the ready state? Just we are going to consider A. Okay, so starting the set the status of static equal to one means is that algorithm or DFS or traversal is ready to travel source to a destination to find the goal node. Okay, so then node in G. Right, so push the starting node A into the stack. Okay, stack and set its status equal to 2. Okay, the one is ready state. Okay, the 2 means the waiting state. Okay, the waiting state to reach the adjacent node of your starting node. Okay, the next one is the repeat step 4 and 5 until stack is empty. Okay, the pop the top the node n. Okay, so process it and set its status at 3. Okay, so the status is going to be updated as a 3 means it is a processed. So proceed state. Okay, it is a process state or proceed state. Just we can tell everything. Okay, so push on that stack all the neighbors n that are in the ready state whose status is equal to 1 and set their status equal to 2. Okay, when there is when vertex is ready, just we are going to push into the stack. Then again this status we are going to update equal to 2. Wait 2 means that traveler is waiting for visit the adjacent node of your starting node. Okay, that the waiting state. Then exit. Okay, when we are going to exit until the stack is empty. Okay, when the stack is going to be empty, then the DFS traveler is going to be exit from the tree or crab. Okay, so finally it will produce some effective optimal result to the users. Okay, so this is some specific algorithms we are going to use to solve or to visit all the nodes from your tree and graph. Okay, the next one is for example, just I given one graph for your understanding. This is from the directly given on a graph using the data structure concepts. Okay, so let us understand the working of a DFS algorithm or DFS travel cells. Okay, we are going to choose the all the nodes and we are going to choose the all the adjacent node from the given graph. Okay, so you see here this I given here and then all the nodes. So how many nodes are there? 1 2 3 4 5 6 7 8. Okay, so total 8 nodes are written here. So each and every nodes their adjacent node also just given here. Okay, so next one is what is a node A. Okay, so as per alphabetic order, just I given, don't get the confusion from here, the tree or graph, I given from H to all the nodes. Okay, for based on this alphabetic order, just I given the adjacent nodes. Okay, so for A, okay, so this one is A. So what is the adjacent node of this A, B, and D? Okay, so B and D. Okay, the next one is next starting vertex is a B. Okay, so A is now is a node. Now the starting node is a B. So now B is a starting node. Okay, so what is the adjacent node of adjacent node of B? Okay, so C and F. Okay, see here C and F. Next the cursor will move, the travels will move to the next is C. Okay, here it will see what is the adjacent node of the C. From the C, the 3 adjacent node are there, G, E, H. Right? So C, G, H. Right? So next one, G. Now the traversal, the traversal or here the starting vertex is selecting as a G. Okay, G means 2 adjacent node are there, H and E. H and E. Okay, so like Versa, just we are going to use visit all the nodes are present in the tree or graph. So for E, B and F is a adjacent node. For F only A is a adjacent node. See here F only one node is adjacent node of F. Okay, then also for D also only one node F. Then H also only one node A. Okay, like this, just we are going to measure the all the adjacent node of your all presented vertices in your tree or a graph. Okay, so this one is the first step. Okay, so what is the next step? Just we are going to operate the stack concept in your given graph. Okay, so based on this steps and algorithm, just we are going to follow now. Okay, first is what, which one we are going to consider starting node of your a given graph or tree. Okay, that one we are going to push into the stack. Okay, see here, we will see step by step, one by step by step. Just I will explain you. Okay, consider this one is here a given tree or graph. Okay, let's start consider visit the all the present node in the graph or tree using the DFS travel set. Okay, so what is the step one? First to push H into H onto the stack. Okay, here now we are going to consider H is the starting vertices in your given tree or graph. Okay, so now the H is here in the stack starting point. So that starting point, the starting vertices, just now we are going to move into the stack. Okay, so stack just H. Okay, first H is here starting point. That was we are going to consider in this stack. Okay, so now in the stack. Okay, now in the stack we have here H, right? So we push it into the H into here, right? Clear, right? So the next one is the step 2. So pop the top element from the stack, that is H. Okay, this one is here now is a top element. Only one element are present in the stack. Okay, that one we are going to pop. Okay, so pop the top element from the stack, that is H. Okay, and print it. Okay, now just we are going to use print the particular starting vertices, or what is the top of the stack that we will print into the in the pop. Okay, now push all the neighbors of H onto the stack that are in the ready state. Okay, so what is the neighbor state of your or adjacent node of your H? Only A, right? Already I given. So on H is only A, right? So H is only A, adjacent node is there. So now we are going to push that particular A into the stack. Okay, now print H. Okay, done. Then next stack, next adjacent node of your H. Okay, the A. So now stack A, right? Clear? Next one, the step 3. Okay, like this, just we are going to visit all the presented nodes in your graph or tree. Then we have to do. Then finally, finally the stack will be empty. That time, just we are going to produce the result as the all the nodes are visited or not. Okay, the next one is step 3. Okay, step 2 is over. Then step 3. Again, now in the stack A is there. Okay, see here. Now in the top of the stack, A is here. Now in the stack, A is here. Okay, so again now just we are going to consider, now it is starting vertices is A. So now just we are going to print A in, we are to pop into print vertices A. Then we are going to push the push all the adjacent node of A into the stack. Okay, so push the top element from the stack. Sorry, here pop the element of the stack, that is A, and print it. Now push all the neighbor of A. Okay, all the adjacent node of A. So which one is the adjacent node of A here? B and D. See here, B and D. Okay, so now just we are going to write the print A. Okay, now print A. Then we are going to take the adjacent node of the A is B and D. So now in the stack, B and D is there, right? Okay, so B and D. Okay, see here, just we have to write like this. B and D is there. Okay, so B and D is there. Then next one, just we have to pop the element from the stack, that is a D. Okay, why we are going to take the D? We have the two adjacent node of A. Okay, a D and B. Okay, first just we push the B into the stack. That is in the first. Second one we push the D into the stack. Okay, so now which one is the top of the stack? D is the top of the stack. Okay, now just we are going to take the D as a pop element. Okay, so pop the top of the element from the stack. Which one is a pop top of the element? D. Now we are going to use the pop. Okay, pop means the print. Okay, so now we are going to write print a D. Okay, so already B is there. right? So push all the neighbors of D onto the stack that are in the ready state. Okay, so for if it is a D means which one is a neighbor state of D? Only F is there, right? Only F is there, right? So now already B is present on the stack. Okay, only we will take on top of the stack. Okay, so already B is the in the stack. Okay, now F if the F, now we are going to take adjustment node of your starting it is a D. Okay, so F. Okay, now it is a F. Okay, again now let's see here the pop of the element from this stack into the F because it's the top of the stack is F. Okay, so now again we are going to print the F. Then push all the neighbor of the F onto the stack that are in the ready state. Okay, see the F now the starting node is F, right? So here only what is the neighbor node of F? A, right? So here A is already is visited. Okay, so already is visited node is A. Okay, so A already visited, B is visited, D is also visited. Now A, F we are going to take. Sorry, B is not yet visited, right? Only D, H, A, D. Now we are starting vertex is F. Okay, so F is already just a node of your F is A. Okay, so A is already is over, right? So again, just we have to move to the just we have to print this F and we have to now it will already is visited, right? So it is not applicable. Then again, just now it is a B C B it is considered. Just F will be removed from your stack. Okay, so now the only one vertices are present in the stack B. So now so B is the starting vertices. Okay, now just what we are going to do. So B is the F is visited, then B, right? So B, now pop the top of the element from the stack is a B and print it. Now push all the neighbor of the B onto the stack that are is ready state. Okay, so from B, which one is a neighbor node of your B? Okay, C and F, right? So already F is visited. So we can't visit one more again to the F. So only vertex is C. So now just in the stack is C, right? Only the adjacent node of B is C. Okay, so now again just we have to continue. Pop the top of the element from the stack that is C and print. Okay, now print C stack. So what is the now the C is the static element. Okay, so what is the adjacent node of your C? Here we have the three elements E, G, H. E, G, H. Okay, so here what the H is already over, E is there and G is there. Okay, now just you have to write E and G. See here, E and G. Okay, so now just what is E and G, right? In the stack E and G. Okay, next. So which one is the top of the stack? G, right? So now the pop the top element from the stack G and push all the neighbors. Okay, now consider this G is the starting elements. Okay, so already H is over, B is A is over, D is over, F is over, D is over, C is over. Now C. Okay, so from C, from G, what are the elements we have? Adjacent element H and E. Okay, so H already is over, so it will not consider. Then E, right? So E just we are going to print now. Okay, so now here also G is already listed. Now E also we are going to take. Right, so again the pop-up table stack E push all the neighbors. There is no adjacent node presented in the tree or a graph. Okay, so all the nodes, all the vertices are visited using the DFS travel cell. Okay, now that stack is empty, right? So nothing is there, right? So now all the graph node have been traversed. Okay, so and stack is a empty. So the DFS algorithm have visited all the vertexes are presented over the tree or graph using this algorithm. Okay, DFS algorithm. Okay, this is visited, and finally they will produce the effective output to the users. Okay, so like this, just we are going to use a DFS algorithm or DFS traversal algorithm very effectively for given the graph or tree. So the next one is textbook, the same textbook and the reference book. So there are some references that I have used to refer all the content about the DFS algorithms. Okay, if you have any doubts, just free feel to post the comments in the comment prompt. Just I will I clarify you after that one. Okay, so we'll see in the a new concept in the next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.